Hello, my name is Amadou Jallo. Um, Today, we're going to talk about atomic structures and interatomic bonding. We're going to talk about chemistry, and we're going to take chemistry outside the classroom. And the chemistry we are studying today is chemistry for material science and engineering. And we're going to take chemistry outside the lab. And let me give an analogy of how taking chemistry out of the classroom looks like. The difficulty of taking chemistry out of the classroom or out of the lab is like taking poverty out of Africa. You see, taking poverty or eradicating poverty out of Africa is much more easier than taking chemistry outside the classroom. You see, there are a lot of factors that culminate in taking or are responsible for the poverty or the backwardness of Africa. And I'm giving Africa as an analogy because I'm from Africa. I'm from Sierra Leone. And there are a lot of factors, both internal and external factors, that are responsible for the lack of development in Africa. And today, in my analogy, I'm going to focus on the external factors. And these external factors are one, the dependency of our economies in donor. And I want anyone to challenge me on this theory of mine, that I've never seen or read from any historical book any country that transformed itself from third world to first world as a result of donor giving to that country. So these donor agencies like the IMF, the World Bank, they think they are doing good, but in actuality they are doing more harm than good. And these agencies or international countries or organizations view Africa not as in a form of countries, but rather in a form of this here. They view us based on our resources. We have what they want, so they come and stay. They don't want to leave. And we know when somebody have what you want, you stay with that person no matter what. You don't leave that person. And we have what they want. And we should not bother ourselves for them to leave, but rather understand and able to use these things that they need from us, which is our resources here. You see, in the Berlin Conference that led to the division of Africa into countries was because of the resources that are coming from Africa. And this is the actual map. This is how they view us. So it's high time we start viewing ourselves like this and understand the importance of this map and able to use these resources to develop our countries. And we should not, however, be discriminatory or forcing these institutions or people who are trying to help to leave, but we should learn these things and utilize them. Instead of exporting them out of our continent, we should start to manufacture and produce them within the continent and then export the finished products. So taking chemistry out of the classroom is as difficult or more difficult than eradicating poverty out of Africa. I'm going to save the internal factors for another lecture. So let's start. Let's start from the atomic structure of elements. So, but in actuality, we need to understand what is atoms and what atoms are made up of. And for us to understand this, we need what we call quantum mechanics. And studying quantum mechanics is beyond the scope of our discussions. But however, I would encourage you to study quantum mechanics. Quantum mechanics is the study of the microscopic details of elements. And somebody might say why we have to study the small scales, the small details of materials. Why not we just study the macroscopic, that the bigger picture of things? Because at the end of the day, the bigger pictures is the ones that matters the most. Well, most of the properties of materials you see in your daily life, materials that you deal with every day, are highly influenced by, or their properties are highly influenced by the microscopic level, the microscopic details, meaning their thermal properties, their electrical properties, and their magnetic properties, their mechanical properties, and optical properties, and corrosions. All these properties of materials are highly influenced by their arrangement inside the material, their atomic arrangements. So we need to understand quantum mechanics. We should familiar ourselves with the small scale, the invisible scale, for us to able to understand what is happening at the bigger picture. Another analogy I love to give is when you have a piece of puzzle game, you have to arrange the smaller pictures for you to understand the bigger picture. So at the end of the day, when you arrange the small pieces together, when you put them together, then you can get the bigger picture. So in my next video, we're going to see atoms, we're going to see the periodic table, and we're going to see how materials or elements are arranged in the periodic table. So check out my next video for the continuation of chapter 2, which is atomic structures and interatomic bonding in material science and engineering. Thank you.